Hey everybody. So we're getting into 9.2 today, showing that a quadrilateral is a parallelogram. All right, so we're still focusing on parallelograms in this section, okay, but you'll see as we go through these problems, the idea is the quadrilateral a parallelogram? That's going to be the question. In the last section, we were told we had parallelograms, and then we were able to do and use the rules. Okay, on these ones, we're wondering, are these parallelograms? You'll see though, a lot of these problems kind of start to become similar to the last lesson. Okay, it's just the context of how they're being asked. All right, so go ahead, take a second, get this title here, and you can draw yourself a parallelogram. I put a little question mark in it because, that's what we're wondering. Is it a parallelogram? Okay, so copy this. Okay, so to answer the question of whether or not a quadrilateral is a parallelogram, we have to see if it falls into some of the rules for parallelograms. All right, and that's where this slide right here comes into play. Okay, some of these rules, or most of them, are ones we learned in our previous lesson, though it's still a good idea to get them in the context of proving a quadrilateral is a parallelogram. So go ahead and take a couple minutes and get these 5 rules here, and then we'll go over them. Okay, so ways to prove a quadrilateral is a parallelogram. Number one, first thing we can do is show that both pairs of opposite sides are parallel. All right, that's the definition of a parallelogram. So if we can show that opposite sides are parallel, yeah, we've got a parallelogram. Okay, the second way we can show it is to show that both pairs of opposite sides are congruent. Okay, if we can show that opposite sides are congruent, we can say, yes, we have a parallelogram, which is one of the rules we learned in the last lesson. Okay, the third way we can show we have a parallelogram is to show that both pairs of opposite angles are congruent. Okay, so opposite angles, if we can show those are congruent, then yes, we have a parallelogram. I add a little something to this one as well. I say that also if we can show that all consecutive angles add to 180, we also technically will have a parallelogram. Okay, that's just a reminder, these consecutive angles, the ones that are side by side, okay, they add to 180, but it would have to be all consecutive angles. So, these consecutive ones, these consecutive angles, these, and these, all of them we need to add to 180, the 2 angles side by side for us to say, yep, we have a parallelogram. Okay, this fourth one, the reason why I put a box around it is because it's the new one. Okay, so here's what it says. To show that, or to prove that we have a parallelogram, we just need to show that one pair of opposite sides are both congruent and parallel. Okay, so that's kind of a little different than what we learned before. But yeah, if one pair of opposite sides, so in this case, these opposite sides here and here, if we can show that they're both congruent, equal to one another, as well as parallel to one another, we can say that yes, this thing is a parallelogram. Okay, so that one's kind of a little new. The last one here is dealing with the idea that if we can show that the diagonals bisect each other, then we have a parallelogram. Again, we learned this in the last lesson, but yeah, remember, these are our diagonals. There's one of them, and there's another. Okay, if they're being bisected, cut into congruent halves, both of them, we can say we have a parallelogram. Okay, so yeah, a lot of review from the last section, but we got some new stuff in here, and it's a new context, a new way of thinking about these problems. So let's try some out. Okay, so go ahead, get this first example, get the directions, get these 2 potential parallelograms, and we'll do these together. Okay, so are the quadrilaterals parallelograms? This is a yes or no problem, okay? And if yes or no, why or why not? Okay, so we need to kind of give an explanation of why we're saying yes or no. So let's take a look at this first one here. I guess we didn't number them. Usually I do. We can call this one number 1, this one number 2. Okay, so on number 1 here, here's what I noticed. We have opposite sides that are congruent. Okay, but one thing I'm just thinking in my head, these opposite sides, we don't know if they're congruent. Okay, if they told us they were, that would be one way of saying we have a parallelogram. Okay, but we have opposite sides congruent, just one pair, but we also have that same pair of opposite sides parallel. Okay, and if you guys remember, this is our new number 4 way of proving that a quadrilateral is a parallelogram, one pair of opposite sides congruent and parallel. That's exactly what we have right here. Okay, so on this problem, we can say yes. Okay, and the reason why is let's, we don't need to write out the entire thing, but let's just go ahead and say one pair opposite sides congruent. We'll use the shorthand for that. And parallel, let's use the shorthand for that. If you guys remember, that's the two vertical lines. Okay, and I guess put them a little closer so it doesn't look like an 11, something like that. Okay, so yeah, the answer on that one was yes. Let's take a look at number 2. Okay, again, we're dealing with side lengths, all right? So here's what I know. For when we're given all 4 side lengths, I need all or both pairs of opposite sides to be congruent. I notice that, this side length is congruent to this one, those opposite sides are congruent, but are these opposite sides congruent? No, this one's 7 inches, this one's 8 inches. Okay, so since both pairs of opposite sides are not congruent, we cannot say this is a parallelogram, so we'll say no, and we'll give just that reasoning. Both pairs of opposite sides not congruent. Okay, if you want to put like not in like capital letters, that's kind of the big reason why not congruent. Okay, so yeah, pretty easy problems as long as you know the rules. So I'm gonna have you guys try a couple of these. It's gonna be basically the same direction, so you don't need to copy that again. Go ahead and get this shape here and tell me whether or not yes or no it is a parallelogram, and give me a reason why you're saying yes or no. Give it a try. Okay, so we're dealing with angles on this one, right? Okay, here's what I know about angles of a potential parallelogram. Both pairs of opposite angles must be congruent for us to say that we have a parallelogram. Okay, on this problem, they're not giving me all of the angles. Obviously I know that these opposite angles are congruent. The question is are these opposite angles congruent, these green ones? Okay, well, here's the thing. We can figure it out. Okay, if you guys remember, we started to memorize that the 4 angles of a quadrilateral, they add up to 360 degrees. All right, and that might not be a bad thing to add into your notes because I don't think we've actually technically written that in our notes. Okay, but let's go ahead and just put that little note there. Maybe put like a star next to it. 4 angles of a quadrilateral add to 360 degrees. Okay, so yeah, that is always the case. No matter what, the 4 angles of a quadrilateral will add to 360, something to start to memorize. Okay, so we can actually figure out this missing angle since we have all of the other, angles. So just like what we did with triangles, where we would subtract it from 180, we can do the same thing here. We can take 360, we can subtract all 3 angles, so 115, 115, 65. Okay, and just to double check, I'm going to do this on my calculator, even though I'm pretty sure it's going to give me what I expect. So let's see, 115 minus 115 minus 65, and yeah, it looks like I'm getting 65 for my missing angle. Okay, so are opposite angles, both pairs of opposite angles congruent? Yes. Is this thing a parallelogram? Yes. Okay, so yes, and then we'll say because both pairs of opposite angles congruent. Okay, cool. So yeah, that is those problems. That's just making sure you know the rules. Let's keep moving along. Okay, let's try another example here. It looks like we're given diagonals, so go ahead, take a second, draw this, get your directions, and we'll do this one together. Okay, so this is saying for what value of x is CDEF a parallelogram? Okay, so what does x need to be for this thing to be considered a parallelogram? All right, well, here's what we know. We have diagonals here, right? We have this diagonal and we have this diagonal. All right, here's what we know about a parallelogram. For this thing to be considered a parallelogram, these diagonals must bisect one another. They must be cut into 2 congruent halves. This one is cut into 2 congruent halves, and that means this one will also need to be cut into congruent halves. Okay, so basically the idea is to figure out what the value of x needs to be, we need to set them equal to one another, and then we can solve. Okay, so really the math that we're doing isn't not any different than what we did in the past. I'm going to say that this needs to equal this. Okay, it's more just the idea of the different way of thinking of it. These need to be congruent for this to be a parallelogram. So that's why I'm setting them equal to figure out the value of x that would make them equal. Okay, so here we go. We got it. Let's go ahead and solve here. I'm going to take this 3x and subtract it to the left. Okay, 5x minus 3x is a 2x. Bring down the minus 8. Here's the thing on the right. These cancel, right? Okay, we don't have anything else over here. Remember, when that happens, technically that means there's a 0 over here. Okay, and then solving for x here, I'm going to do this in my head. Add 8 to both sides, so I get 2x equals 8. Divide both sides by 2. Looks like x is going to equal 4. Okay, so, did we answer their question? For what value of x is this thing a parallelogram? Yeah, x must equal 4 for this thing to be considered a parallelogram. Okay, if x does not equal 4, this thing is not a parallelogram. That's the kind of context of this problem. All right, so let's see where we're going from here. Let's try one more example together, and then I'm going to have you guys try a couple on your own. So same directions here. What value of x, makes this thing a parallelogram? Go ahead and copy this shape, and we'll try it out. All right, so here's what I know. First of all, we're dealing with angles, right? Here's what we know about angles. Opposite angles must be congruent, okay? And by the way, I do not have any opposite angles here, okay? But these angles here are consecutive angles. And here's what I know about consecutive angles of a parallelogram. They are supplementary. They add to 180, right? Okay, so the value of x that makes this thing a parallelogram, to figure it out, these consecutive angles must add to 180. So that's what I'm going to do. I'm going to say, all right, x plus 10, that angle, plus this angle, 2x plus 20, they must equal 180. Okay, just be careful. It might have been tempting to set them equal, but no, these angles are not equal. They're consecutive, so they add to 180. Okay, so from here, we have variables. They're already on the same side, which is nice. We can just combine them. So an x and a 2x is a 3x. Same thing with the 10 and the 20. That gives me a 30. Okay, 180 on the right. Again, I'm going to do this in my head. Subtract 30 from both sides. I get 3x equals 50, or sorry, 150. Okay, and then divide 3 into both sides. X equals 50. I kind of got ahead of myself. All right, and yeah, there it is. For this thing to be considered a parallelogram, x must equal 50. Okay, if x doesn't equal 50, this thing is not a parallelogram. That's the idea. Okay, so I'm gonna have you guys do the same thing, same directions. You probably don't need these again. So go ahead, try these two problems out. Figure out the value of that x must be for these to be considered parallelograms. Go ahead and copy them, give them a try. All right, so first thing, both of these problems are dealing with angles. All right, on number 1 here, first thing to realize is we have opposite angles. All right, here's what we know about the opposite angles of a parallelogram. They must be congruent for it to be considered a parallelogram. All right, so to figure out the value of x that makes this a parallelogram, I must set these equal. So 2x minus 3 needs to equal 5x. Okay, and from here, I'm going to start solving variables on both sides. I'm going to take the 2x and bring it over to the right this time. So it's gone. I have a negative 3 on the left. On the right, looks like I have a 3x. Okay, solving for x, get rid of the 3 by dividing. Negative 3 divided by 3 gives me negative 1 equals x. I'm going to flip it around. X must equal negative 1 for this to be considered a parallelogram. Okay. On number 2, again, we're dealing with angles, but be careful. They are not opposite angles. They are consecutive angles, all right? And, if I were to put little arcs through them, I'd probably do something like this just to show that, no, they do not have the same measure. They are not equal, okay? But I know since they're consecutive, they add to 180. So that's my equation on this one. This angle, x, plus this angle, 3x, needs to equal 180 degrees. Okay, that's the hard part. From here, we're just kind of solving. So, x and 3x gives me a 4x equals 180. And let's see, I'm going to do this in my calculator because I want to. 180 divided by 4. Looks like we're getting 45. Yep. And there it is. Again, x must equal 45 for this thing to be considered a parallelogram. Okay, so we got one more I think I'm going to do with you guys. Yeah, so one last example. We're going to end it here. Go ahead and copy this. I'm going to do one part of the problem. You're going to do the other part. Give this a copy of this and we'll start out together. Okay, so pretty much the same idea. It says show that the quadrilateral is a parallelogram for the given values. Okay, so it's a little bit different. They're giving us x and they're also giving us y. They want us to show that it's a parallelogram given those two values. All right. Well, let's see if it is. Okay. To see if it is, we need to plug these numbers in and see if we actually get things that are congruent. So here's the first thing. Let's start with x. Okay, this side length deals with x and this side length deals with x, right? Okay, so I know that for this thing to be a parallelogram, these opposite sides, they must be congruent. So let's just start with that. I know that x plus 14 needs to equal a 3x. Okay, or really that's the question. Does it equal, or are they equal to one another when x equals 7? Okay, well, let's plug it in and let's find out. Okay, so I'm going to plug in 7 for x, so I get a 7 plus 14 on the left. Okay, on the right, I have a 3 times x. Again, x, we're plugging in 7. All right, and let's see, again, I'm going to put a little question mark here because that's really what we're wondering. 7 plus 14 gives me 21. 3 times 7 gives me 21. So since the opposite sides are equal when x equals 7, yeah, right now, that is working so far. Okay, we can't say yet that this thing is a parallelogram because we need to also check these opposite sides. All right, but we're on the right path. All right, we know that one pair of opposite sides are congruent. We now need to figure out if these pairs of opposite sides are congruent. That's where I'm going to let you guys try these out. Okay, so go ahead, do the same thing for these opposite sides. Make the equation, plug in your value, see if it actually equals one another. Give it a try. Okay, so on this one, I know that this side length 5y minus 4 must equal 2y plus 8. All right, and let's see if when y equals 4, if we actually get an equation. So again, I'm going to put a little question mark over that. Are they equal when y equals 4? Let's find out. Okay, so 5 times y, 5 times 4 minus 4. Does that equal 2 times y, 2 times 4 plus 8? All right, well, let's see. This is giving me a 20 minus 4, which gives me 16. Okay, and is that equal to, looks like we're getting 2 times 4 is 8, 8 plus 8 is 16. Okay, so sometimes what I like to do is put a little check mark like on this one, yay, those worked out. Yeah, so did those. These worked out. All right, so since both pairs of opposite sides are congruent when x equals 7 and y equals 4, yeah, we basically already, we answered it. It said show that the quadrilateral is a parallelogram for the given values, and we just did. Okay, so I guess ultimately, if we wanted to, we can just say, yes, it's a parallelogram. Let's make it obvious. Parallelogram. There we go. Okay, cool. So yeah, a little bit more practice on parallelograms. These are really important rules to remember because as you guys will see, as we go through chapter 9 and get into more specific types of quadrilaterals, a lot of these rules are still going to apply to the new shapes that we look at. So that's why I really wanted to make sure we have this nailed down. All right, guys, I'll see you later. Bye.